Hello everyone, today I thought it'd be a fun little video to break down a graphics card and to kind of show you all of what's inside of it. After doing some very brief research, I will be breaking this down into a couple categories. The first one being integrated circuits, then it'll be power stages, passive SMDs, protection and logic, and then timing. So if you are interested, don't forget to subscribe to the channel and enjoy. Today I'm breaking down a GeForce 1050 Ti, and this has a GP107 processor chip inside of it, and that handles all of the graphics rendering. Then you have the VRAM modules, usually 4 separate GDDR5 memory chips on a 1050 Ti, typically made by Micron, Samsung, or Hynix. That stores texture data. Now the VBIOS or EEPROM chip, it's a small 8-pin chip, often from Winbond or Maytronics, that stores the card's firmware. Next is the main PWM controller. This chip manages the power delivery for the GPU core. The memory PWM controller, it's a smaller controller dedicated to specifically managing power for the VRAM modules themselves. Then you have the logic and management ICs or integrated circuits. They're small chips used for like fan control, temperature monitoring, and communicating with the motherboard. And then also gate drivers, tiny ICs that help the PWM controller switch the power delivery MOSFETs on and off at very high speeds, causing heat, of course. And voltage regulators, LDOs, microchips that provide very specific low voltages for the GPU's internal logic. Now on to the power stages. MOFETs, high and low size, the actual switches that turn on and off the power thousands of times per second, and it might be combined into a single driver MOS on this specific card. Chokes or inductors, usually labeled R22 or R47. These are gray and black cubes that smooth the choppy electricity from the MOFETs into a steady stream. Next you have input capacitors, often smaller rectangles or silver cylinders that stabilize the 12-volt power coming into the stage. Output capacitors, bulk caps, also I have labeled here for some reason. These sit at the very end of the stage to store a final reserve of power right before it enters the GPU core. Then you have phase doublers. These tiny chips split a signal from the PWM controller to drive 2 power stages at once for better efficiency. Next, onto the passive SMDs. These start with the MLCCs, otherwise known as the multi-layer ceramic capacitors. The most common part on the board, they look like tiny brown or tan rectangles and are used to decouple or filter out the electrical noise so the chip gets clean power. SMD resistors, tiny flat black rectangles, often with a number code on the top. They limit the flow of electricity to protect sensitive components or tell controllers what settings to use. Ferrite beads. These look like slightly larger dark gray or black rectangles. They act as high frequency filters to prevent electromagnetic interference from leaking out of the card. Current sense resistors or shunts. Relatively large flat metal plates, often green or black, with a label like R002 or R005, and they measure how many amps the card is pulling. Tantalum polymer capacitors, flat, often black or yellow rectangular blocks, usually located behind the GPU core or on the back of the board. They provide high capacity, ultra stable power storage for the GPU's most intense calculations, according to this, of course. Moving on to protection and logic. These start with fuses, tiny white or green surface mount blocks, usually near the power conductors. They act as circuit breakers that blow to prevent the card from catching fire during a short circuit. Then you have diodes, small black part with 2 leads. They act as one-way valves for electricity, ensuring power doesn't flow backwards and damage sensitive logic chips. You have logic gates as well, tiny 5 or 6 pin chips that handle if-then hardware check, for example preventing the card from turning on if a power rail is missing. Temperature sensors, ICs that sit near the GPU and VRM and monitor the heat and tell the fans to spin of course. Voltage monitor IC, specialized logic chips that report real-time power consumption data back to the GPU and the computer's operating system. And then you have TVS diodes, I might not say this right, but transient voltage suppressors, high-speed protectors that clamp sudden spikes in voltage to prevent them from hitting the main chip. Now we're moving on to timing. First thing is the crystal oscillator, a small silver rectangular metal can, often labeled with a frequency like 27. It vibrates at a precise rate to act as the primary clock for the GPU. And then you have the clock generator IC, a small chip that takes the single beat from the crystal and multiplies or divides it to create different speeds for various parts of the card, i.e. the memory or the core. And then you have RTC, not to be confused with RCT from JJK. No, these are small resistors and capacitors dedicated to maintaining the timing for the card's internal sleep and wake states. And there you have it. That is everything in the card. And if you're anything like me, you love the look of the PCB itself. I mean, these have just so much things in it that are printed with such precision. It is insane how they work in general, and I hope to do more videos like this in the future. So once again, if you're interested, please subscribe, and thanks for watching.